Alright, so what I'm going to talk about right now is the Beers Law Lab, what you need to do to complete that lab report, um, and hopefully make these terms a little more clear. Again, I'm sorry that I jumped the gun on this lab. We probably should have waited till closer to where we're at right now in the class to do it. So in this lab, you were measuring the absorbances of different solutions after you prepared them. You had a stock solution, and you used that to make 4 dilutions. Um, so it does tell you that in step 1 of the procedure, you're going to need to show your work for your calculations and describe how you prepared it. So make sure you do that for both 1, and I believe it also asks you to do that for one of the solutions that you made in step 2. Make sure you have your heading in your data table as part of your lab report. So you're going to want to have this information complete. And again, you want to make sure you have that second column complete with the math, the calculations you did to determine how to prepare your solutions. So right there, you need to make sure under your data tables that you have the calculations for the stock solution of cobalt 2 chloride. You describe how you prepared it, include your lab equipment. Same thing for the dilution that you just choose to describe to me. You get to pick the concentration. It doesn't matter to me which of the 4 you use. Again, show me calculations and then describe with lab equipment how you prepared that dilution. Question 1, again, I think if you've completed your data table, that should be pretty straightforward. Also think about the graphs that we made in the computer lab. What type of graph is it? Is it representing a linear function? Is it representing a quadratic function? Talk about what that relationship would be. I suspect that you're going to see it's going to be terms similar to what we talked about when we did gas laws in your first chem class. Number 2 we've already done. I do want to make sure that you realize you need to print out a pair of graphs to put with your report, and you also need to sketch a graph copy in your lab notebook so you have that for reference purposes. Again, I would use like maybe a fourth of a page in your lab notebooks, enough that you'll be able to read and know what you were trying to describe. You want to photocopy and shrink them, you can do that too. That's totally up to you. I'm going to go ahead and talk about number 4, and then I'll go back and talk about number 3. 4 says that Beer's law works well to determine the concentration of colored solutions by their absorption measurements in terms of how much light is able to be transferred or transmitted through the solution. It would not be helpful to determine the concentration of a salt solution. Why would this be useless? I want you to think about saline solutions. Think about physical properties you can observe, as opposed to the cobalt 2 chloride solution and the copper 2 sulfate solution we prepared. Why would NaCl not be a very effective ionics compound to use Beer's law with? Okay. Number 3 says use the interpretation or the equation of your line of best fit to determine the concentration of 4 solutions. The first one, the cobalt 2 chloride, that has an absorption of 0.5. For part B, the copper 2 sulfate solution with an absorption of 0.7. For part C, the unknown solutions you measured in lab, there was 1 for the cobalt 2 chloride and there was 1 for the copper 2 sulfate. I do not care which format you use, and I suspect for part B, I don't know how many of you got absorption readings greater than 0.7 for that copper 2 sulfate solution. You may not have a choice but to use the line of best fit for that one. But you can use either interpolation or your line of best fit to answer these questions. And I'm going to go through and show you an example of interpolation. And I will then also show you how you could use your regression data, which is your line of best fit, to find what the concentrations are of these 4 solutions. All right, so I'm going to have to switch gears for a second and bring you back to this PowerPoint that I showed you when we first started talking about Beer's law. And so this hopefully looks a lot like your graph. Then we had our data points. I know that not all of our data points fit on the best fit line, but you should have your best fit line. And then you have your values for that regression line, and it gave you the format y equals ax plus b. Again, y is representing what's on your y-axis, which is your absorbance. X is representing the concentration, which is on your x-axis. The slope is giving you the A value, and then the B would be your y-intercept. So if you're going to use your regression line to find your concentrations, you know your absorbance readings, you know your y values, and you're trying to solve for the concentration, which would be your x. So you would substitute in what your regression data gave you for A and B. You would plug in your absorbance for your y and see what x value you would get at that absorbance reading. Option B, again, is to use the graph to get you relatively close to the concentration. You're going to need to use a ruler, and you're going to find the absorbance reading or the approximate absorbance reading for your unknown solution, or the two that I asked you to look at. You're going to draw a straight line across to your best fit line. That point is going to give you an x and a y value, the x being your concentration, the y being your absorbance, and you should be able to draw another straight line down to get your concentration value at that absorbance reading. So basically you're going to make a square. Again, you need to do this with a ruler. Don't just guesstimate it. That will not be accurate enough, and I will not give you full credit for doing that. So either use your equation of best fit, or use the regression data, sorry, not the regression data, use the graph to be able to extrapolate out what your values of concentrations are for those 4 solutions, and then you should be good to go. You need to make sure you tell me again what you decide to do in order to answer question 3. Sorry, I was saying extrapolation, it's interpolation. It's been a long weekend. I hope that helps. Again, if you need any more help with this, I will be more than willing to go over questions on Wednesday.